Hi students, welcome to physics class. Today we will discuss about torque acting on electric dipole in uniform electric field. We know that when there exists a static charge Q, there will be an electric field E developed due to this static charge. If we want to calculate the intensity of electric field produced by this source charge, the charge which produces the electric field is called as source charge. In order to find out the electric field intensity produced by source charge, we have to take a test charge, that is unit positive test charge. Unit positive test charge. If we place a unit positive test charge at a point P in an electric field, then this test charge which is placed at P will experience a force which is equal to E into Q naught. Here E is the electric field intensity and Q naught is the test charge which is placed at a point in an electric field. If we divide the force experienced by test charge with the magnitude of that test charge, we will get the electric field intensity at that point. That is, the electric field intensity depends on the force experienced by test charge. If the force experienced by test charge in an electric field is greater, then the electric field intensity will be greater. If the force experienced by the test charge which is placed in an electric field is lesser, then the intensity of electric field is also very low. That is, we can estimate the intensity of electric field by the force experienced by test charge. Now we have to calculate the torque acting on electric dipole. An electric dipole is a system of two opposite and equal charges. The magnitude of two charges are equal, but one is a negative charge and another one is positive charge, and these two are separated by a distance 2a. Then this system is called as electric dipole, which consists of two charges separated by a distance 2a. These two charges are of equal magnitude but opposite in direction. One is positive and one is negative. A test charge placed in a electric field experiences a force F is equal to E into Q naught. Here we have to place an electric dipole. In an uniform electric field E. That is, a system of two charges separated by a distance 2a must be placed in an electric field. If one charge is placed, then there exists a force F is equal to E into Q naught. For a dipole, there exist two forces, the one acting on positive charge whose magnitude is equal to electric field intensity, and the test charge Q plus Q. So the direction of electric field and the direction of force will be same. On negative charge, the force acts in a direction opposite to the electric field, whose magnitude is given by electric field intensity into magnitude of charge q. Here the direction is opposite to the direction of force acting on plus q. Let us say this is F1 and this is F2. We know that uniform electric field is represented by parallel lines, parallel straight lines. Non-uniform electric field is represented by a curved lines. If the electric field is represented by curved lines, then we can say that the electric field is non-uniform. For uniform electric field, we have to represent the field lines as parallel straight lines. So, for an electric dipole which is placed in an electric field, we have two forces acting on plus q and minus q charges. These here F1 and F2's, the forces acting on the charges, the magnitude of forces acting on the charges is equal. We can clearly say that F2 is equal to EQ and F1 is equal to EQ. So magnitude of F1 is equal to magnitude of F2, which is equal to, we can say, F. Now we have to calculate the torque acting on electric dipole. When two equal and opposite forces, these two forces are equal and acting in opposite direction, when two equal and opposite forces acting on a system, then there exists a torque. Let us say this is a system and there exist two forces acting in opposite direction, then this system will rotate. The force which is responsible for the rotation of a system is called as torque. We have to calculate the torque acting on that system. We know that the distance between 2 points, two charges in an electric field is 2a. Here minus q plus q, which are at a point A and B, are separated by a distance 2a. This electric dipole is making an angle theta with the electric field line. The electric dipole is making an angle theta with electric field lines. Now draw a perpendicular line from A and extend the force line in a backward direction. Then we get an intersection point C. We know that this is F1, whose value is equal to E into Q, and this is F2, whose value is equal to E into Q. We already know that magnitude of F1 is equal to magnitude of F2, which is equal to F. We can say it is equal to E into Q. Now the torque can be written as R bar cross F bar. Here R bar is a perpendicular distance between line of forces. R is the perpendicular distance between line of forces and F is the magnitude of force. Magnitude of force. Here, in order to find out R bar, which is the perpendicular distance between the lines of forces, here the lines of forces are, first one is F1 and second one is F2. The distance between these line of forces we can write as 2a, but we have to know the perpendicular distance. For that we have drawn already a perpendicular which gives the perpendicular distance between the line of forces. These two are the line of forces, and the particular line which is drawn here, AC, gives the perpendicular distance. AC gives the perpendicular distance. Now AC can be calculated by using sin theta formula in a triangle ABC. Sin theta can be written as opposite side divided by hypotenuse. Opposite side to theta is AC divided by hypotenuse is AB. So we can write sin theta is equal to AC divided by AB means 2A. AB means 2A. Therefore, which implies AC, the perpendicular distance, is equal to 2A into sin theta. Now, we have obtained the perpendicular distance as 2A into sin theta, and we have to substitute the magnitude of force. The magnitude of force we have already written as F is equal to EQ. Here F1, F2 are equal, which is equal to F. The magnitude of two forces are equal, which is equal to E into Q. So we can substitute here E into Q. So by rearranging the terms we get 2A into Q, 2A into Q into E into sin theta. Here 2A into Q is called as P, E sin theta. Here 2A into Q is called as P. P is, here P is equal to 2A into Q, which is equal to electric dipole moment. Electric dipole moment. Electric dipole moment. Here P sin theta is similar to AB sin theta, which can be expressed as A bar cross B bar. So we can write this torque expression as P bar cross E bar, which is similar to A bar cross B bar, which is equal to AB sin theta. This is the expression for the torque experienced by an electric dipole which is placed in an uniform electric field. Here the electric dipole experiences two equal and opposite forces which are responsible for the torque acting on that electric dipole. That's all. Thank you.